what I want to do today, well, I just heard the last bit of the presentation, the introduction. So yes, we got kind of two operations. One is more research-based. It's both at MIT in Boston and at MIT in a new office in Singapore. And then the other one is more about design and projects that actually become built architecture. But what I want to do with you today, given your interest and the crowd here today, is actually looking more at the research thing and try to tell you something about this idea that people talk about today much, which is smart cities. Now, we hate the word smart cities. That's why actually our lab is called SENSEable City Lab. But there's actually something quite interesting behind this idea of cities becoming more intelligent. And let me try to show you what I mean by that. Well, if you look at this picture, that's a picture that people used to be really fascinated in the 1990s. In the 1990s, people thought that our world would become more and more virtual. So much so that some people, like Gilder, thought that because of this, actually cities would die, would disappear. That's Gilder in 1995, we are headed for the death of cities. Cities are leftover baggage from the industrial era. Well, this tells you how difficult it is to predict the future, because no prediction actually could have been more wrong. We now know that actually cities have been thriving over the past few years. That's a picture from a couple of years ago from China, Tianjin. China itself is planning to build more cities than all of humanity ever built during this century. And we also know that half of the world's population now lives in cities, and this number could actually swell to 5 billion by 2030. So what has happened is actually that all of these technologies that change our life over the past 10, 15, 20 years. Think about, everything, the way we work, the way we live, the way we meet friends, the way we shop, the way we move in the city. All of this is very different today than what it was just 10 or 15 years ago, or 20 years ago when we barely had cell phones. So all of this actually is not going to pose a threat to physical space and to cities, but actually it's creating a new interesting hybrid dimension. It's a dimension where bits and atoms, the digital and the physical, you see on this slide, actually are converging. And that's actually what some people call the field of smart cities. Now, if this is the kind of the general framework for what is happening today, I wanted to share with you just a few examples of how this can actually help us perhaps better understand our cities, and ultimately, which is the thing that actually interests a lot of you here today, is how this then can result in savings, energy savings or savings at the systemic level. So I didn't focus too much on buildings. Yes, we do also a lot of buildings that try to incorporate the same principles in our design office, but I try to focus today more in the presentation about the broader trends happening. More and more we're able to use tags in order to understand what happens in a space. And what we did in this project, for instance, is look at this computer. Now, if you take this computer here, you know everything about it today. Every chip, you know where it was produced on the planet, how it moved on the planet, how it became this machine. That's what you see on the map over there. However, a few years from now, when you stop using it and you throw it away, you know very little about it. Sometimes a machine like this one will end up where it shouldn't end up. A lot of e-waste from Europe is shipped not legally to Africa, from the United States to Asia. So our idea was, well, could we actually design a little tag, like the tag you see there, almost like a miniature cell phone that we could put on trash, and then better understand what happens to trash. Does it go in the right place or in the wrong place? Are we using the right amount of energy to move all the waste around? So what we did a first deployment. You see it here. It was the first deployment. We had like 500 volunteers and 3,000 pieces of trash in the city of Seattle. We put a little tag on all of them. These little tags we designed, like miniature cell phones. And after tagging all of them, we started following them. So you see the day of deployment. In the city of Seattle, 3,000 objects. And then how they go to some of the main landfills next to Seattle. But then a big surprise that nobody expected. Actually, how far things started to travel. Sometimes in crazy way. Look at that tracer went all the way to Chicago and then went to down to Baja California. And how much trash actually going from the west to the east coast of the United States for thousands of miles. And you know, we've been working on the project with several partner companies, like with Qualcomm for designing the chips, but also with Waste Management, a waste management company. And actually, everybody was very surprised because today, everybody does a small piece of the chain, but actually, this was the first time that you could see the whole chain actually being traced together. It's a little bit like when you go to hospital, they put a tracer in your blood, and they follow your blood through the body. Well, how can you do the same thing in the scale of an entire city? Now, if you do this, what you can learn from it? Now, the first thing you can do is, if you're an engineer, you can take all this data, this massive amount of data. You know, but incidentally, this is what many people today call like big data, which is really big. It's, if you take all the data produced by humanity from the beginning till 2003, well, think that the same amount of data, you know, in that type of data, you had Shakespeare, you had the Bible, you had everything, you know, from the beginning till 2003. Well, the same amount of data we produce now every 24 to 48 hours. And, you know, it's not the same quality of data, but the sheer amount of data is really big. And so if you take all of this, if you're an engineer, you can actually look at the traces and, for instance, ask yourself how you can design a more optimized system, how you can reduce the energy, for instance, for moving all those things across the country, how you can use this as a way to design a better city or a better system. The other thing that's very important is that actually, if you take all this data and if you share it with people, then you might also promote changes of behavior. You know, the data tells us something about the impact of our actions on the environment, and then you can change what we are doing, the way we live, once we know better how to quantify the results of those actions. Something, for instance, at the end of the project, somebody came to us and said, you know, I used to drink water in plastic bottles every day and throw them away and forget about them. And you know, after the project, I can't forget about them anymore. I know they go a few miles from home, they will go to a landfill, they will stay there forever, and so because of that, I'm not drinking water in plastic bottles anymore. So that's the second point that's very important, how all of this data shared with people can actually help promote behavioral change. There's a third thing we discovered that was more unexpected, and that happened more recently when a burglar came to our lab at MIT and stole a lot of things, including some of the tags that tell you where they go. And this is what happened. Sorry, video should be starting. All right, so, you know, thank you. Thank you. So, you know, that's about how today we have a better knowledge of the environment. But the same thing actually applies also to other type of flows, like, you know, energy flows. So if you look at this, you know, we started looking at the MIT campus. And that's a scientific article we did on that. And when we look at the MIT campus, here what you see is, at the top, you see energy consumption in buildings, how much energy we put in buildings. And then what you see at the bottom is actually how many people are there. And what you see is it's totally uncorrelated. We heat our buildings even when nobody's there, as we know. You know, basically think about our homes. Usually they're heated during the day when we are in the offices. And think about our offices. Usually they're heated during the night when nobody's there. So if you could just actually modulate energy better over time, that could be a great saving. And you know, something that people have been talking about for a long time, then just because we got new interfaces, think about an iPhone, a more easier way to interface with it can become a big success. Something like Nest, as you might know, it was acquired just 10 days ago by Google for quite a significant amount of money, but something very simple. The idea to have a thermostat that actually is online, so it learns from you. First of all, it's not too bad. It looks quite nice on the wall. And then it learns from you, so it knows when you're going back. It tries to anticipate your needs. And then also, you can control it through a small app. And so you can have all the kids in the family playing games about who's going to save more energy. So it becomes a very easy way that you can modulate actually energy in a much better way. And this is something very small. It's selling a lot in the United States and also now across the world. But something like this can actually have a big impact. If you think about it, the global oil prices actually go up when there's a cold winter on the east coast of the United States, because so much energy actually there is used for heating huge homes, and sometimes when nobody's there, just wasted energy. Well, that's you modulate over time, but think about you could actually modulate this over space. So that's actually something we are working on at the moment. It's called local warming. It will be presented in June this year. We started doing a test outside MIT. It's quite cold this time of the year, so actually, can you actually think about a bubble of heat that actually just follows you? You need to heat the whole room, but actually if there's just 10 or 20 people in the room, you can actually just concentrate the heat where the people are, not only over time, but actually over space. You concentrate it. And then that heat bubble can actually be customized based on what you want, on the temperature you want. Well, this was the first thing. Entering MIT, you actually would jump on a carpet, and then from there you have this heat bubble following you, customized as you wanted. And that's what we are working on. That was the first installation, but how we can actually then save a lot because we concentrate things where we need it. While in the old paradigm, in the 20th century paradigm, it was much more difficult to actually control things in a fine-grained, dynamic way. Now we can do that, and that can apply to many different things. In one of the fields where this will apply a lot, I know this is, is a broader field than what some Enova and some of you are looking at, but it's about mobility. Mobility is going to be very interesting over the next few years. The first thing is, again, that we know a lot about what is happening in the city in terms of mobility. What you see here is actually the city of Lisbon tracking, using billion and billion of data from the taxi fleet, but you can use the taxi fleet or cell phone network. Our lab was one of the first ones to use cell phone data in order to understand how the city lives, what happens in the city. And then we got all this data, you can then analyze it. What you see here, for instance, is New York. And if you look at New York, taxis, pickups, and drop-offs, you see the two colors here. That's actually next to the airport. You could ask yourself, well, what if people could share a trip, could share a taxi, or could share a ride? And the very interesting thing that you find, the very interesting thing that you find out is that if you do that, if you analyze mathematically, again, billions and billions of data on trips in New York City, you could actually run the city in a much more efficient way with just a fraction of the car. In terms of taxis in New York City, you could actually reduce the taxi fleet by 40% and actually still take everybody to their destination at the same time, give or take 1 minute. So that's something quite interesting. You got all this information, and then it can help us to optimize, again, the mobility system. There's another trend that's happening in mobility that's actually inside the car, not only at the city level, but also inside the car. We know a lot about what is happening. The car itself is becoming much more sentient. It knows a lot of what's going on inside. In this project, for instance, we've been looking at the car and how it can learn about how the driver behaves, about, for instance, the level of stress and frustration of the driver.
The drive, it was incredibly stressful. It was the most stressful drive I've ever been on. Nevertheless, I think we have a lot of great content to measure road frustration, because I'm certainly frustrated at this point.
about the car?
So we were just sideswiped, and right now my stress level should be through the roof. We got the information, you know, we'll have to process the data and see where it's really at.
Jesus.
So then take the two trends I mentioned. The first one is that actually we know a lot about the city. We got all this real-time information about the city, about how it behaves, and all of this data can help us to design new urban system. And at the same time, we actually have a lot of information inside the car. The car itself is becoming, if you want, more intelligent or smarter. Well, out of these two trends, something quite extraordinary is going to happen over the next few years. And that is actually self-driving cars. Now, self-driving cars, and here you see a self-driving car, how it sees what is happening around itself. So it's a LiDAR scanner, so it tells you, like the human eye tells you in 3D, all of what is around the car. Self-driving cars, then, are interesting not because you don't need to keep your hands on the steering wheel, not because you don't need to, you will be able to text in the car, or sleep in the car, nap in the car, or kiss in the car. That's not the point. The interesting point is that when you go self-driving cars, then the total distinction between public transportation and private transportation disappears. In the morning, the car can give you a lift to work, and then can give a lift to anybody else in your family, or anybody else in your neighborhood, or in your city, or in your social network. So in a certain sense, you don't have anymore the difference between public and private transportation. And actually, we just did a paper, is not published yet, but some scientific analysis on Singapore, where we have part of our lab. And you could run a city like Singapore with 6 million people. You could run the whole city, taking everybody to their destination at the same time with 1 car out of 5. You can remove 4 cars out of 5 in the city and actually take everybody to their destination. What is the reason? The reason is that today we got a huge infrastructure, we got a huge amount of energy actually embedded in the car, in the mobility infrastructure, but that infrastructure most of the time is not doing anything. Actually, our cars are just parked somewhere for most of the time, and we use them for very little during the day. So that becomes quite interesting. Or the other thing that you can think about is, think about a city where then you don't need to have traffic lights anymore. You got this kind of intelligent management of flows, and you can think about flows of cars magically crossing without bumping into each other. Something like this. Well, don't try it yet. But this is really what we'll be able to do in a few years from now. So this is radically going to change about mobility, autonomy, so self-driving cars are going to change a lot, and that is going to have huge consequences in terms of energy and the energy we can save on the system. So this is something we're working on. Also, we try to use it also to address more mundane problems. On the MIT campus, I don't know if you've been on campus, but the campus is in Cambridge, next to Boston. The campus is really, really complex. It's really a messy campus. Every building has a different number. If you're not familiar with it, it's very easy to get lost. And every year in September, this was actually, we did this project last September, so a few months ago, there's plenty of new students coming, and some of them actually have difficulties in finding their way, especially Harvard students. So we designed this project. We designed this project in order to help them, like this.
Welcome to MIT. Where would you like to go? Follow me, please. The Computer Science and Artificial Intelligence Lab is the largest research lab at MIT and one of
To your
the world's
right,
most important
the Media
centers of
Lab.
information technology
To your left,
research.
the Stata Center.
Follow me, please. Approaching your destination.
You have arrived. Welcome to SENSEable City Lab.
Goodbye.
Thank you. I'll stop here. Just wondering, should I? Hello? So should I? I'm not sure what the script is now, but anyway, the presentation is.